Hello everyone. In this video, we are going to discuss preemptive shortest job first numerical problem. In this particular problem, you'll be provided with the arrival time and the burst time of the processes. Let's work on this particular example. The first thing you need to do is to plot an empty Gantt chart like this and then plot the arrival of the process on the Gantt chart. For example, here P1 came at time 0, P2 it came at time 5, P3 it came at time 12, P4 it came in at time 2 and P5 it came at time 9. So like this, plot the arrival of the process on the empty Gantt chart. Now to proceed next, how preemptive SJF works is, it compares the newly entered process burst time with the currently executing process remaining time, and whichever process has got shortest burst, that process will continue to execute. For example, here at time 0 only P1 is there in the system, hence P1 will start executing. It will continue executing till time 2. So now at time 2 P4 comes into the system. So P4's burst time is 10 and P1 burst time is 11, but it has completed 2 seconds of execution, hence P1's remaining time is 9. So comparing 9 with 10, P1 has got the shortest job, hence P1 will continue to execute. In this way, preemptive SJF compares the remaining time of the process with the newly entered process burst time, and whichever is shortest, that process will continue. So let's go ahead and work on this problem. So this is the complete Gantt chart of this particular numerical example. So let's get started. So at time 0, as P1 is the only one process, it starts executing. It will execute for 2 seconds, and here you can see P4 comes in. P4's burst time is 10, whereas P1's remaining time is 9. So P1 being the shortest, it will continue to execute until time 5. So at time 5, P2 comes into the system. You can see P2's burst time is 28, whereas P1's remaining time will be 11 minus 5, 6. So 6 being the shortest, P1 will continue to execute. So it will continue to execute till time 9. At time 9, P5 comes into the system. P5's burst time is 16, whereas P1's remaining time is 11 minus 9, 2. Hence, P1 being shortest, P1 will continue to execute. And it will complete its execution at time 11. So in this Gantt chart, you can observe that the execution of a process is depicted using a solid line. And whenever the process completes its execution, put an arrow mark like this. And whenever the process is waiting, depict that using a dotted line. For example, here, now P4 came into the system at time 2 and it had to wait for the CPU. So that is depicted using dotted line till 11. Similarly, P2 it came at 5 but it did not get CPU. Depict that using a dotted line till 11. P5 it came at time 9 but it did not get the CPU. Depict that using a dotted line till 11. Now we are at this point. P1, as it completed execution, the CPU has to schedule next process. So the next process in computation are P2, P4 and P5. P3 has not yet arrived into the system. So P2's burst time is 28, P4's burst time is 10 and P5 burst time is 16. So P4 being the shortest job, it will start execution. So P1 will continue to execute, and at time P1 will start at 11 and it will continue to execute. So at time 12, P3 arrives into the system. So we need to compare the P3's burst time with the P4's remaining time. P3's burst time is 2 and P4's remaining time is 10 minus 1, 11. So 10 minus 1, 9. So P3 being the shortest, it will preempt P4 and it will continue to execute. So P3, it will start at 12 and it will complete the execution at time 14. What about P4? It will continue to wait. P2, it will continue to wait till 14. And P5, it will continue to wait till 14. Now at time 14, after P3's execution, we need to schedule the next process. So remaining processes are P2 with burst time 28, P4 with remaining burst time of 9 and P5 with burst time of 16. P4 being shortest, it will start at 14 and it will continue to execute for 9 seconds and it will complete at 23. So the next burst after P4, P5 is 16 and P2 being 28. P5 is the shortest, so it will continue to execute and complete execution at 39. 23 plus 16, 39. After this, only P2 is left out. So it will start at 39 and it will execute for 28 seconds straight and it will complete the execution at 67. So in this way, wherever the process is executing, you depict using a solid line, and when the process completes execution, put an arrow mark. Whenever the process is waiting in the system, depict that using a dotted line. So one thing to observe here is this preemption, everything happens only until all the processes arrive into the system. Once all the processes have arrived into the system, it will be just like a normal SJF. So the preemption happens only until all the processes arrive into the system. So once you're done with this Gantt chart, computing the wait time and turnaround time is very simple. So looking at this, let's calculate the wait time. We'll plot the processes like this and we'll calculate the wait time. So you can see P1 has no dotted lines, so its waiting time is 0. Whereas P2, its waiting time, the length of this dotted line is the waiting time. The length of this dotted line gives you the waiting time. So how to calculate length? So 39 minus the end minus the start. 39 minus 5. 39 minus 5, 34. So P2's waiting time is 34. P3, as you can see, there is no dotted line, hence P3's wait time is 0. P4, please pay attention here. P4 has got two set of dotted lines here. So we need to calculate the length of these two dotted lines. So 11 minus 2, end minus start, 11 minus 2 plus 14 minus 12. So 11 minus 2, 9, and 14 minus 12, 2. 9 plus 2, 11. So P4's waiting time is 11. P5. P5 waiting time is 23 minus 9. It is 14. So P5's waiting time is 14. Once you calculate the waiting time, turnaround time is simple. You just add the waiting time to the burst time. So turnaround time is nothing but wait time plus the burst time. Wait time plus the burst time. So turnaround time is of P1 is 0 plus 11, 11. For P2, 34 plus 28, it is 62. P3, 0 plus 2, 2. P4, 11 plus 10, 21. P5, 14 plus 16, 30. So turnaround time is just a wait time plus burst time. Once the turnaround time is calculated, you need to calculate the average waiting time and an average turnaround time. Just add all of this divided by 5. And for average turnaround time also, add all of this divided by 5. That will give you the average waiting time and average turnaround time. So you may be asked to compute the number of context switches. Let's leave the first and the last context switch. What is context switch? It is switching the CPU from one process to the next process. So how many context switches are happening in this particular example? We'll leave the first and the last context switch. So here 1 from P1 to P4, then 2, P4 to P3, then 3, 4, 5. So there are totally 5 context switch, leaving the first and the last context switch. If you add that, then it will be 7. So in this way, you can solve the preemptive shortest job first. Be little careful while computing, while drawing the Gantt chart. If your Gantt chart is perfect, then average and computing the average and turnaround time is very simple. Hope this helps you. Thank you.